Okay, welcome to MAE 113, Calculus for the Liberal Arts. My name is Richard Kohar, the instructor for this course, and in this lecture we're doing Elasticity of Demand. This is lecture 22. 22. Elasticity of demand. So I'm just looking in the comments. Someone wrote, by the title of this lecture, the content is crossing over into microeconomics. Should be reassured or concerned at this synergy. I would say you should probably be more assured because I'm coming from the philosophy that memory is associative. So as soon as you have something that you already know and you can associate it with something, then it should be easily you should be able to remember it easier. And then, of course, just follow the math. Yes, of course, we're going to follow the math. And then, of course, it's always fun to see a mathematician go outside his comfort zone and use real-world applications. So we'll see how I remember everything about this. So elasticity of the demand is a measure of how sensitive the quantity demanded of it is to its price. So I can just say it's a measure of sensitivity. Of the quantity demanded. So it's like how much people want. Demanded. Compared to its price. So what we usually think of demand in terms of versus price, okay, and this is usually how it goes. Like, I mean, we could probably find some weird cases. So what we're going to do is we're going to put the price, so it's the price, and then we have over here is the demand. So if it's really low in price, that means that there's a high demand. If there's a really high price, then there's low demand. And somewhere in between that we connect these dots, we'll just say it's a smooth curve, something like that. So they usually say that's a typical demand function. So this is typical. I would be okay paying $20 for an album, but you start to increase the price to $40 for a CD, then I start to probably not want to buy it at that point. So again, the demand of it will go down as the price increases. What elasticity is, or elasticity of the demand, elasticity of the demand, it gives the change the change in percent in quantity demanded when there is a 1% increase in the price. And usually we expect that change is going down. So for instance, like if we said that the elasticity is 2, then that means that for a 1% increase in the price, that I would expect 2% to go down in demand. Okay, so in terms of my macroeconomics, hopefully, if I am saying something incorrect, make sure you say something in the chat. Okay, so, yep, price goes up, demand goes down. That's, I don't want to say obvious, but it seems reasonable. This is where we start to introduce some notation. So let's introduce our notation. So we're going to say for price, we're going to say that is P. And we're going to say for this demand some sort of function of P. So in fact, that this curve here, it would be a function of P. So what's the next thing I'm going to do? We want to look at the change. So what I'm going to do, and I'll pick out, oh, I have a red pen. No more pink. We're going to use red today. Okay, so I'm going to pick out a point here. And at this point here, we're going to call this, we'll call this P here. And yeah, right here is the function of P. And then we're going to go just a delta P, a little small change in the right direction here. So we'll call this P plus delta P, and this would be the function at P plus delta P. So that is what we're going to call our demand function. So in this case, we have that. And the other small thing that we're going to watch out for, so this is the price, and this would be the demand. So that's the quantity. I could say quantity demanded. And that quantity we usually write as X. And in this case, so we'll say that X is equal to that function of the price. Okay, so I have that. Okay. So the first thing I'm going to say is that we're going to suppose that a unit price, what week is our next test on? I believe that will be not next week, but the following week. So I am thinking that our test should be on the 25th of March. That's what it's looking like at the moment. So hopefully that answered that question. Product. And we're going to say is increased by delta P dollars. So it goes from P to P plus delta P. Okay. Then the quantity demanded, we're going to say it drops. And it drops from, so it's going to be from this one to this one. And that's considered our drop. From F to P. So this is a change of, there we go. Okay. So what we're going to do is it's the elasticity, yeah. So I'll say that the percentage change in unit price that's 100%, and we're going to look at the change in the unit price. So it's the change in the unit price, so that's the delta P over the actual price P. So that's the change and the actual price. And make sure that, there we go. So usually demand and price are on the opposite axis. It may confuse people to do it this way. Okay. But for the time being, I'm going to stick with just showing that it's the price and just showing that the demand. So again, he's saying that it's going to be X over the P. And yes, we're used to seeing it like that way too. Yep. So yeah, you can say the number of demand and then the price. So yeah, you can actually have it both ways. So again, you can write, so in this case I have like X equals F of P, and you can actually write it the other way as well. But hold tight, I do need it to work like that. Okay, so I got this. This is the change in the unit price. And then I also need the change, the percentage change in the quantity demanded. So again, it's 100% and it's the change. So I got P all over F of P. So again, that is the change in quantity, demand over the change in the price, over the quantity demand. There we go. Okay, so I have these two that I need. So that is what I'm going to, throw that over away. Here's page 2. So what we're looking for is the effect that a percentage change in price has on the percentage change of the quantity. So what we're going to do is it's a ratio. So it becomes like this. It's the percentage change in quantity demanded over the change in unit price. Okay, so now I substitute these in. I already have this, which was 100, which is F of P plus delta P minus F of P over, I have 100, and then I'm using the unit price here. So the unit price here, which is 100, and I have delta P over P. Now, what I have now is I can start to do some simplification. I can cancel out this 100, so that doesn't matter. I'm going to use the top part again. Now, what is in the, I'm going to rewrite this again then. Now, equivalently, I can put this into the denominator and this up into, I can leave that. So in the denominator, I'll have f of p and delta p. This p comes up into the numerator. So there's my p, and I'm left with f of p plus delta p minus f of p. Okay, so everyone's thinking I probably have made a mess. Where I'm going with this is that I know, for instance, that the derivative is, I want something like this, right? Now I have this as, this is what my derivative is that I want. What I'm going to do is I can actually split that up. So I can actually put this over, like switch these. So what I'm going to do is split this up so that I have a p over here. I'm going to put the f of p on the right hand side here, and I'm going to put the delta p on the left hand side. I can do that. That's okay because multiplication is commutative. And I still have this. And what we say is that is approximately equal to our derivative when that price change is small. So I switch to my approximation here. So I'm going to replace that with f of p, so f prime at p times p all over f of p. And that's the formula for elasticity. So when they write the formula for elasticity, they'll say it's the elasticity of the price is equal to, they'll write, they usually write P first. So the price times the change in the price, the change in the demand, all over the demand. The other thing that they usually do is that they add a negative. Now the reason for that was, if we go back to our function here, that if I'm looking at this, I'm subtracting this point from this point, it's going to be negative because it's actually lower. So it's always going to be negative. So what they usually do is they'll put a negative in here to ensure the value is positive. So there we go. So how many people have seen the elasticity of demand function like that? So that is the elasticity of demand. Not written like that. Okay. We've been using absolute value for the same effect in microeconomics. Okay. Yep. So that's the elasticity of the demand. And so what I'll do here is I'll just kind of define it. This is, again, there's some assumptions. My assumption is that F is differentiable. At that point P. And then we also have that X equals F of P. That's our demand. That's our demand function. Or quantity demand function. Okay. And what then they usually do is they say that the demand is, they have three terms. They usually write elastic, inelastic, and unitary. Unitary, which is unit meaning just one. So if it's elastic, it's if it's greater than 1. It's inelastic if it's less than 1. And unitary is if it's equal to 1. Okay. So examples. They want some real-world examples. 3. So again, I'll write up here. This is our elasticity formula. We have the negative of the price times the demand, the change in the demand, over the demand. Okay, so then examples. So we have some demand equation. So I think this is where other people like Cade was saying that it's kind of usually flipped. So we'll say that we have P, which is our demand. We have, here's the price, and we have negative 0.02 times X plus 400. And we'll say that this is on the domain from 0 to 20,000. And what that describes is the relationship between the unit price in dollars. So the unit price in dollars and X demanded. And we can say like it's some sort of car stereo system. So like this is kind of the price. If there's X car stereos that they want, then this is the price that they will sell it at. So a question like that would be like, find the elasticity. Now our function isn't written. Our function isn't written in the form of this. We need it to be different. We need it to match like this. So in this case, I have P is a function of X. And instead, so what I could write here is this is P of X. And what I really want, or what I need, so we need X of F of P. And we have P of X is equal to so how do we do that? we take this equation. So I have P and the first thing I'm going to do is I'm going to solve now for x. So instead of having it written for P, we'll write it for x. So solve for x. I will take the P here and bring the 400 to the left-hand side. And then I will divide both sides by the negative 0.02. And so I'm left with x is equal to, I have P over 0.02, and I can't forget about the negative. So there's 2 cents. Okay, so this is actually 1 up here. So how many times does 2 cents go into a dollar? There's 50 times. So that's minus 50p. So I have a minus here, and then that minus and a minus, that's a plus. Now I have $400. How many 2 cents are in that? Well, there's 2, goes in twice, and then multiply by my number, or my zeros. So I should get 20,000. Okay, and that is my demand function. Written in terms of P. Okay. So I have this part right here. I have my f of P, but this also requires me to find the first derivative as well. So, and also, this is nice because if I take the derivative of this, it's just minus 50. Okay. So then substituting in my formula for, the elasticity, I have P times minus 50 all over. And in the bottom here, I have 20,000 minus 50p. So I have a positive and a positive here, so that'll become plus. The other thing too is I can factor out a 50. So I have 50 up here and 50. And what do I have? So that leaves me with 50 goes into 20,000. That's 400 minus, and then the p is left. So I can cancel out that. And so it simplifies to p over 400 minus p. So that is our elasticity equation. So then they'll say B, which is like, what's the value of the elasticity at 100? What does that mean? So substituting our value in for P, which is 100, I get 100 over 400 minus 100, or 100 over 300, or 1 over 3. And that is less than 1, so that implies it's inelastic. And also that means that if I was selling, that product at $100, then, so, selling at $100, that an increase of 1% in the price, in the unit price, that will decrease approximately 0.33% in demand. Then we could ask, what value of P makes the elasticity equal to 1? So all you have to do then for that is P over 400 minus P equals 1. And you're solving for it so that I have 400 bringing that over to the right-hand side. I have 400 minus P. P on the left-hand side. Bringing that P over to the left-hand side again, I get P plus P. Gives me 400 or 2P. Or dividing both sides by 2 gives me 200. So, therefore, the elasticity is equal to 1 when P is equal to 200. And we could also do something like D, which is calculate what it is at 300. And same idea again. So you have 300 over 400 minus 300. And that is 100, which is equal to 3. So that is greater than 1, which implies that it's elastic. And so that means that selling at $300, if you increase of 1% in the unit price, it will decrease about 3% in the demand. Okay, so again, the unit price doesn't always just affect the demand, but it also affects the revenue. The revenue also responds to the changes in the unit price. So revenue also responds to changes in the price. Is everyone okay with that so far? I'm just about to write the revenue. This is the revenue that we've seen previously in this course. So we have that we have X, which is the number of units demanded, times the price of X. And we can also, so that's in terms of X. We can also write this in terms of the price as well. So again, we said that X equals F of P, so I can replace that, F of P times, and this is just the price now. So you're probably asking me, like, how does this relate to elasticity? Elasticity. Well, what we can do is we're going to take the derivative and we're going to find that there's a combination of the terms that actually gives us the elasticity. So I'm going to take the derivative of this. I'm going to be looking at my rate of change in the revenue function. So actually what I'm looking at is I'm looking at the marginal revenue function. So the idea then is if we're looking at the marginal revenue function, if I'm looking at it at very specific numbers, if I say it like 100 units, then what I'm looking really at is the revenue that I'm expecting to get on the next unit that I'm going to sell. So that's the revenue for that unit that I'm going to sell. Now, why am I interested about the elasticity is because maybe I want to adjust the price and I want to see how that affects the revenue that I'm going to get for that next unit that I'm going to sell. So I'm going to take that derivative now. And again, the marginal means take that function, whatever it is, it could be the cost, the average cost, it could be profit, but the marginal means that I'm going to take the derivative. So taking the derivative of this, I'm going to use now the product rule. So it's the derivative of the first function. So in this case, it's f of p times p plus, I leave the first function alone and take the derivative of the second function. But in this case, p is already, you're already told what that value is. That p is a number. So that is a constant. And when we take the derivative of constant, that's 0. Or sorry, that's... No, when I'm taking... Yes. So this ends up being, you know, what... yeah. That's definitely... It's not a constant. I have just p, so I'm just taking the derivative with respect to p. Sorry, don't listen. It's p. So I'm going to take the derivative of that, and that's going to be 1. There we go. Okay. So I'm still going to try to jam the idea of elasticity into here. So what I'm going to do is I'm going to do a little bit of an algebraic manipulation. So I have, what I've done is just multiplied and divided by f of p. And so that I'm able to factor that out. So what I'm left with is f at the derivative of f of p times p all over f at p plus 1. Now right there, that is equal to the negative of the elasticity. So the marginal revenue function is equal to f at p, or the demand, times 1 minus the elasticity. Okay, so now we can do a little bit of analysis on this. So we have those three cases where of the elasticity. So we have where it's elastic, inelastic, and unity. So if the elasticity is greater than 1, so that means that it's elastic. Just a second, make sure that I'm not... Okay. So we said that this is elastic. And what I'm going to do is I'll rewrite that formula again. So if it's elastic, that means that, well, again, this is positive, so that's greater than 1, which means that this term in here is actually negative, so that's less than 0. And because that's negative, and this is also usually positive, the demand is usually positive, so hopefully, then this makes this whole thing negative. So it's less than 0. So it's negative. So what that gives us is that if the elasticity is greater than 1, so if it's elastic, then an increase in the price will cause a decrease in the revenue, which is what we kind of, that's our intuition usually. Then we also have that if it's going down in price, it should go up in revenue. So for those that have taken microeconomics, is that making sense so far? So again, if the elasticity is greater than 1, that means that the revenue, or this is the marginal, so again, that's looking at its rate of increase or decrease, which means that it's going to be negative. So that's our, that's our first derivative, which describes the revenue function if it's increasing or decreasing. And so what that is saying is that, which means that this implies that it's decreasing. If I look at the elasticity, it's less than 1. So we're looking at the inelastic. Okay, perfect. Good. Yep, it matches our textbook's graphics. Which textbook are they using? Like the microeconomics textbook? Yes. Okay, perfect. Good. I knew we would get to the right point. Yeah. Okay. Oh yeah. So let's keep going with this. Let's analyze this a little bit more. So this is inelastic, which means that this is less than 1. So I have 1 less than 1. So that means that this should be positive. Parker and Bade microeconomics. Okay. It's been a long time since I've done any economics. So, but it comes back. See, you never know when all this stuff becomes useful, or you have to tell someone or teach someone it. Then the next one. So this is positive, and this one should also be positive as well. So I have 2 positive numbers, so that means that this is positive. So then my first derivative is greater than 0, which implies that it should be increasing. So that means that if I increase in price, will cause, which is kind of interesting. That's good. So you can keep rising the price and you'll increase in revenue as well. And if I decrease in price, that will cause it to decrease in revenue. And lastly, if we have this equal to unity, or unitary, so I'm just writing out that function again. So that means if it's unitary, this is equal to 1. So 1 minus 1 gives me 0, which means that this whole thing is 0. And that implies it's not increasing and not decreasing. So that means that if you jack up the price, so an increase in the price will cause the revenue to stay the same. So just to finish off that, I have like 30 seconds. Wow. All right. So to finish that off, what I have then is this graph. So I have the price of P, and I have Y, and I have my revenue function here that's in terms of P. And so what we found is that at this point here, so I'm going to call this is my Y equals revenue of the price. And that is where the tangent is equal to 0. So that's where the revenue function, or the derivative of the revenue function, or the marginal revenue, is equal to 0. And that is where the elasticity is equal to 1. If it's less than 1, this is inelastic. And this is elastic. And that is when the elasticity is greater than 1. And that's it. I've posted an assignment. Again, please have a look at that. It is now posted on Moodle. There's questions based on what we've talked about. We have the marginal functions in economics. They're referring to the previous assignment, so make sure that you work through that. There's also questions, again, based on the tutorial that we had done on Tuesday. I will post solutions. I will write out the solutions for this, but please make sure that you do them first before looking at the solutions when I post them. It does help. And again, working through the algebraic details and becoming proficient at it is going to pay dividends in the long run. Not actual dividends, but I mean in terms of stress levels will decrease if you have mastered it and you don't have to worry about algebraic hang-ups in your future courses. Is there any questions? I know that we've hit our 50-minute mark, but if there's any questions, feel free to say that in the chat, or again, if you're not comfortable, you're welcome to send me an email, again, at my RMC account. Yeah, exactly. I think that's really important, that you do take some time and work on some of the algebraic skills. Yeah, and I wish that the textbook had some more of those in there, and that's why I had to write out some more for you for the assignment. But will you be holding office hours today? Yes, I will be holding office hours today from 1 to 3 p.m. And make sure that you if you do have questions, stop by. Okay, I think that's all the questions. Again, email or stop by the office hours and we can chat about some of this. So again, thank you very much for tuning in for MAE 113. My name is Richard Kohar and have a great afternoon.